Good morning, class. So we now want to start with change of subject of formula. We have two different questions on the board. They're actually from WAEC. Now, we are asked to make X the subject of the relation. We have been given this relation. P is equals to S plus Sm squared over NR. Note, anytime you're asked to make any alphabet the subject of the formula, what they are trying to say in the question is that make that alphabet to stand alone. Nothing must be attached to that alphabet. In fact, even the alphabet must not be square or must not have anything like a square root or anything like a cube or any other thing. The alphabet must just stand alone. Now, we have this. We are asked to make X instead of the formula. It means that we should make X to stand alone. When you see this is an S. S is being attached to another else that has a coefficient. So we should find a way of making S to stand alone. If you look at this is like a fraction. So the first thing we do is to eliminate this fraction first. To eliminate the fraction, you find the LCM. This is like saying S over 1. This is like saying P over 1. It means this should be the LCM. So the LCM will be NR. This NR. Then we can now multiply both sides by the LCM, which is NR, so as to eliminate the fraction. So we can now say that multiply both sides by NR. So we are going to have NR multiplying P, that's for this, equals to NR multiplying S, that's this, plus NR multiplying Sm squared over NR, which is this. NR can now eliminate NR. We now have PNR, that is for this, to be equals to SNR, that is this, plus Sm squared. Now, we now have this now without any fraction. So, since we want to make S to stand alone, S is common here, we can factorize S out. So we can now say PNR is equals to S into bracket NR plus M squared. Since we want to make S to stand alone, but in this expression now, S has a coefficient. The coefficient of S here is NR plus M squared. To make S to stand alone, we divide both sides by the coefficient of S, which is NR plus M squared. Now, divide both sides by NR plus M squared. We can now divide both sides by NR plus M squared. We can now divide by NR plus M squared. This we eliminate this. Now, we can now have our S now. Our S now is now equals to PNR divided by NR plus M squared. Now, we have been able to make S to stand alone. And that's exactly what the question is telling us to do. That we should make S the subject of the relation. That's the first question. Now, let's look at the second question. Now, the second question says that make K the subject of the relation. We have this. We have T equals to the whole of this inside the root. We want to make K to stand alone. How can we make K to stand alone? The first thing we need to do is to make sure that K is free from anything like a square root, anything. K must be free. But by the time you look at this, you will notice that K has been embedded inside a root. So the first thing to do is to eliminate the root. We eliminate this root so that K will be a little bit free. Now, to eliminate this root in this question, we square both sides. By the time we square both sides, we are going to have T will be squared equals to square root of TK minus H over K minus H. We also be squared. So we've squared both sides. By the time you square this, the square will eliminate the root. So we now have T squared to be equals to TK minus h divided by k minus h. Don't lose focus. Our main target is k. Now we now have this. The next thing to do is to cross multiply. You cross multiply and we can now collect like terms to make sure that k is on one side and the term that does not have k will be at the other side of the equation. So we can cross multiply. This is assumed to be over 1. Cross multiply. T square is multiplying this and tk minus h will multiply 1. T square is multiplying k minus h, which is this, equals to tk minus h times 1, we still remain tk minus h. We can expand this. Tk squared times k will give us tk squared minus t squared times h will give us t squared h equals to tk minus h. Our main target is tk. So now we collect like terms. We make sure that the term that has k will be on one side and those that do not have k will be at the other side. So this one has k, we leave it here, t squared k. This is tk, we can bring it to the other side of the equation, we can bring it here. It's plus here, when it comes here it becomes minus tk equals to minus h. By the time we bring minus t squared h to the side of the equation, it becomes plus t squared h. We now have this. This can be rearranged as t squared h minus h. Now we now have this. Our main target is what? K. K is common, so you can factorize k out here. You can say k into bracket t squared minus t. That will give us our k. Equals to minus h plus t squared h. So we can continue at the other side of the board. Now, k now has a coefficient which is t squared minus t equals to t squared h minus h. This has been rearranged. We can now divide both sides by the coefficient of k, which is t squared minus t. We now say k into bracket t squared minus t divided by t squared minus t. T squared h minus h divided by t squared minus t. T squared minus t, we cancel t squared minus t. So we have k now to be equals to t squared h minus h divided by t squared minus t. We can see that we have been able to achieve that k is now standing alone. And that is the end of question 2. So we'll meet in our next class. Thank you.